This next section is on writing polynomial functions. It's basically backwards of what you've been doing. So instead of giving you a function and asking you to write a new one, or sorry, to find the zeros, I'm going to give you the zeros. So here's the basic idea. So let's say I had this function and I asked you to find the zeros. That means you have to solve this equation. This is a quadratic that factors quite easily. That's okay. Okay, two polynomials like that. That means we set each one equal to 0. I get x equals -2. This one is x equals -4. So what I'm going to give you is I'm going to give you this, and you're basically going to work backwards. You're going to go, oh, okay, if x equals -2, that means that equation came from here. This one came from there. And then this was that factor. This was that factor. And then you multiply stuff back out and give you the final function. And then you throw an f of x in there. That's the whole basic idea behind this, this whole section. Okay, so this one says, given the graph below, write a polynomial function f of least degree, we'll talk about that in a minute, that has rational coefficients and a leading coefficient of 1. So key pieces there of least degree that has rational coefficients and a leading coefficient of 1. So first thing you're going to start with is you're going to identify those x-intercepts. Because remember, x-intercepts are zeros, which means they're solutions to that. So we've got x equals -1, x equals 1, and x equals 3. Now you just work backwards from there. This one, what we would have done is we would add x plus 1 equals 0, and then subtracted 1, and that's how we would have got this right here. So this one produces the factor x plus 1. This one, same idea. This came from x minus 1, though, because we would have added 1 to get it to that point, which means this guy produces that factor. Okay, this one means x minus 3, because we would have added 3 to get it to there, which produces that factor right there. And then we're going to multiply. So we multiply everything together. Anytime you see stuff like this, the conjugates, right, where they're the same thing, they're twins but not identical, I would start with those because it simplifies everything. So x squared minus x plus x minus 1, that's x squared minus 1. Then you bring down that other guy, and we're going to FOIL that out as well. So x cubed minus 3x squared minus x plus 3. Throw an f of x in there, and that's your answer. Now, if you wanted to check these, you could always plug this equation back into Desmos and see if the graph lined up. Now, when it says of least degree, this one is a third degree polynomial that I found because there were 3 intercepts. Now, that's not always the case. For example, if we had 2 imaginary solutions, those don't show up as x-intercepts. Remember, they don't show up. So it is possible that maybe I also had solutions of, plus or minus 2i. Those are missing from that formula. So when it says least degree, it says don't worry about any other formulas, any other solutions to f of x equals 0, because we're going with least degree. And then leading coefficient of 1 just means this guy has to be a 1. Sometimes it'll say a leading coefficient of 2, in which case you would multiply everybody by 2. I'll show you an example of that. Okay, here's the steps. Basic, easy steps. Make polynomials out of all your factors, and then multiply. So again, least degree, leading coefficient of 1. We've got zeros at -2, 2, and 1. This one had to come from x plus 2 equals 0. which produces this factor. This one came from x minus 2 equals 0, which means that gave me this factor. And this one, x minus 1 equals 0. So my original factor was x minus 1. And when you multiply, again, these things are called conjugates, right? Right here, when they're the same thing, but the sign doesn't match, it actually always factors into these two multiplied together, or sorry, multiplies, factors, what in the world, and these two multiplied together. Always. Let me draw better numbers there. So that's a little shortcut. When they're opposites like this, x plus 2, x minus 2, you don't even have to do FOIL. You just have to do FLA. Right? These first ones, FLA, F firsts, x squared, and then the lasts, which is negative 4, and that's it. FLA. No oi. All right, x minus 1, FOILing it out. Minus squared minus 4x plus 4. Throw an f of x out in front of it. And that's your answer. All right, here's one more. We've got zeros, again, least degree. This time it says leading coefficient of 3. So we'll come back to that in the end. We don't need to worry about it right now. All right, 0. So I've got x equals negative 1, x equals 6, and x equals 0. Okay, this one had to come from x plus 1 equals 0, because I subtracted 1 to get to the other side. That leaves this factor. This one is x minus 6 equals 0. So I have this factor. And this guy, it's already equal to 0. When you get this as one of your equations to solve, you don't do anything. So this factor is just x. Okay, we're going to multiply out. Multiplying these two together, x squared minus 6x plus x minus 6 squared minus 5x minus 6. Right? Next thing is this x. This is the same thing as the x out in front. You would distribute that through x cubed minus 5x squared minus 6x. Okay, so then we throw an f of x in there. All right, now let's go back to the idea of this leading coefficient is supposed to be 3. Right now, the leading coefficient is 1. So the only way to turn that into a 3 is to multiply everybody by 3. So we're going to take 3 and multiply every term by it. You can't just multiply the first one. Think of it as a GCF. So now it becomes 3x cubed minus 15x squared minus 18x. Put your f of x out front, and that's it. Okay, next theorem, this one's called the complex conjugates theorem. All it says is if you have a complex number as a solution, something with an I, an imaginary solution, there is always a twin, which is called a conjugate. So if a plus bi is a 0, then a minus bi is also a 0. For example, this is a polynomial function, degree 3 has 2 and 3i as its zeros. What's the other I? Well, if we have positive 3i as a 0, then we have negative 3i. And that's all it is. Is if you have one imaginary solution, you should know automatically you have a second one. Because remember, when you get those imaginary numbers, it came from the square root of a negative something, like let's say 16. And then there's plus or minus 4i from that. every time you had a complex number, there was always that plus or minus out in front. So this one says we've got zeros of 4, 2 plus 3i, and 5i. 2 plus 3i means 2 minus 3i is also a 0. 5i means negative 5i is also a 0. So it says this is a theorem, and it's easy to forget. Just remember that every imaginary solution, there is always a twin, always a conjugate. So again, to find a polynomial, you're going to write each 0 as a factor, and then you multiply by distributing and FOIL. All right, write a polynomial function, least degree, leading coefficient of 1. Okay, so we don't have to worry about that. We've got zeros in 2 and 3i. So x equals 2, x equals 3i, and x equals negative 3i. Right? This one would have been x minus 2 equals 0. Remember, we're walking backwards. So that produces this factor right there. Now, these two have i's in it. It doesn't change anything. You're still going to follow the same process. Pretend that this one came from that equation, which means x minus 3i is the factor. This one's going to be x plus 3i. X plus 3i is the factor. Now multiplying these together, these conjugates right here, these are just like as if it were x minus 3 and x plus 3. So you can go ahead and FOIL those out, but it's really just going to be FL again, right? F, so x squared, and then negative 3 times negative 3, that would be negative 9, but you've got an I in there. If you have I times I, that's I squared. But we all know that I squared is actually negative 1. So this factor becomes x squared plus 9. Then we have to multiply the x minus 2. You've got x cubed minus 2x squared plus 9x minus 18. Leading coefficient of 1, so we don't have to worry about multiplying. Put an f of x out front, and that's it. Now this right here, this multiplying complex conjugates. You can work through this process exactly, get the I squared and do the minus 1. But the main thing it does is it's basically the FL again, so x squared minus 9. This I squared is just always going to change that sign, right? This minus became a plus. So if I had x plus 6i and x minus 6i, that would become x squared minus 36, but the I squared turns that into a plus. So there's another little shortcut for you.